This is Dr. Carroll. Today's video is about virtual function tables. So with polymorphism, we can have a pointer or reference of a base class type pointing to the address of an object of the derived type. For example, we've been looking at a mammal class that's the base class and a dog class that is a derived class of that. And here we have polymorphism. We have the four essential ingredients. We have inheritance. We have a virtual method in the base class. Speak is a virtual method in the mammal class. The speak method is overwritten in the dog class, and we have a pointer or reference to the base class type, mammal, pointing to or referencing the derived type or dog. Okay. So now at runtime, how does the system know which speak method to execute? And the answer, not surprisingly, is virtual function tables. Okay. So there is an overhead involved with resolving which virtual method to use. And this overhead can be expensive. So this is something to apply when it's appropriate, but not just every time. Okay. So each object that has at least one virtual function contains a pointer to a runtime virtual function table. It's invisible to the programmer, which is great. It's just all part of the magic. The virtual function table contains the starting addresses of all the virtual functions in the class, and the constructor establishes these pointers and sets it up for the appropriate methods. So now that we have a virtual function table set up when an object is created, here's how the system knows which polymorphic method to execute. So, and this happens when it's called through a pointer or reference. Otherwise, it's static binding and it's just clear which method to use. One, the runtime system uses the object's address to get to the virtual function table pointer. It then follows that pointer to the table and then looks up the function and then calls it, which is several more steps than just static binding. So the virtual function table overhead is we have to create it and we also have to use it. Every time a method call is used, we have additional steps there. So some more rules for inheritance and polymorphism. If we have a base class that declares a virtual function, it has to implement that function, even if the body is empty. And so a lot of times you'll see virtual functions, the body is empty because we have to implement it. Okay? So in summary, static binding is more efficient because it doesn't have to create the virtual function table, and then during runtime it doesn't have to look up the method every time. But dynamic binding is more flexible. It allows for polymorphic calls. That's it for today.